Hi everyone, welcome back to Math Tutoring. Today's lesson is on radical equations. So radical equations are equations involving roots. So what we're going to do in today's lesson is try to solve some examples. So say you're given the following example and you're asked to solve for x. So you've got root of x minus 3 minus 4 is equal to 0. So for an example like this, what you're going to do first is move the number over to the other side. And when you do that, you're going to get positive 4 because whenever we move a number to the other side of the equation, it becomes a change of sign. So if it's a negative here, it becomes a positive. And at this point, what you want to do is eliminate the root. So to do that, we're going to square both sides of the equation. And whatever we do to the left side of the equation, we have to do the same thing to the right side in order not to change our equation. So this part here becomes root x minus 3 times root x minus 3. And when you multiply two expressions like this, what happens is your answer just equals x minus 3. The root actually eliminates. So you get x minus 3, and then 4 squared is just equal to 16. 4 multiplied by itself is 16. And now you've got a regular equation that you're going to solve. So you're going to bring the 3 over to the other side. When you do that, it becomes a positive. So your final answer is going to be x is equal to 19. So that's your final answer. And if you want to check your solution, you can do that by substituting your solution into your original equation. And when you do that, you get 19 minus 3 minus 4. And then you evaluate that. So 19 minus 3 is 16 minus 4. Root of 16. The root of 16 is 4 minus 4. 0. And 0 does, in fact, equal 0. So that's correct. So the root of 16 is plus or minus 4. But in this case, we just take the positive solution when we're doing equations. And then over here we get 0 equal to 0. So that means our solution is correct. Okay? So we can try some other examples. Let's try something like the following. So we want to solve for x. So say we have the root of x squared minus 6x is equal to x minus 9. So again, what I'm going to do is square both sides of the equation first. And I'm doing that because I want to eliminate the root sign on the left. So what this, oops, there should be a square there. And I'm not actually changing the equation because whatever I'm doing to one side, I'm doing to the other. So when I square this, this becomes x squared minus 6x. And this becomes x minus 9 times x minus 9. So x squared minus 6x. So this here we can FOIL. So we multiply the first terms, the outer terms, the inner terms, and last terms. And when we do that, we get x squared minus 9x minus 9x plus 81. 9 times negative 9 times negative 9. Okay? So here, what we can do now is start collecting like terms. So negative 9x and negative 9x are like terms. So I would go ahead and subtract them because they both have a number and an x attached. So when I subtract negative 9x from negative 9x, I get negative 18. Now here what I'm going to do is bring all the x's to one side and leave the numbers on the other side. So I get x squared minus 6x. When I move, this became a negative, this x squared here, I brought it over here. The negative 6, so this is this one right here, okay? That's that. And then negative 6x, and when I bring the negative 18 to the other side of the equation, again, it changes sign, so you have to make sure to remember that. So when you do that, this eliminates this, and then negative 6x plus 18x are like terms, so I can go ahead and add those, and when I do, I get 12x is equal to 81. And then I divide both sides of my equation by 12 to get my answer of 81 over 12. And then this would reduce to x is equal to 27 over 4 if I divide the top and bottom by 3. And then I can even write this solution as a mixed number. So 4 goes into 27 6 times, and I'm left with 3 over 4. Or you could write your solution as a decimal if you want as well. Okay, so that's how you would solve an equation in this form. So I think it's pretty straightforward. Just keeping in mind the rules of math and just, FOIL, order of operations, etc. And also remembering you can only add like terms, keeping in mind that when you move something over to the other side of the equation, it changes signs, and that's important to remember as well. Okay, so we can try some other examples. All right, so let's try to solve for x. So say we have root of x minus 32 plus root of x is equal to 16. So what I'm going to do here is I'm going to bring this over to the other side. And the reason is I want this to be by itself. I find that a little bit more straightforward. When I bring the root x over to the other side, it becomes negative. The next step is we're going to square both sides of our equation. So when we square both sides of our equation, this one here just becomes x minus 32, and this becomes 16 minus root x times 16 minus root x. So here, now we would FOIL these out, and when we do that, we get 16 times 16, which is 256. 16 times root x is negative 16 root x. 16 times negative root x. 16 times negative root x is negative 16 root x. And then negative root x times negative root x is x. So what happens here when you're multiplying negative root x by negative root x, again, the root eliminates and you end up with whatever's inside. So it's always the same rule. When you're multiplying something like this, you just end up the root, and you're multiplying two things under a root, two algebraic expressions. If they're the same and they both have roots on top, what ends up happening is you just end up with that, and the root eliminates whatever's inside. So same thing here. If I had x minus 32 and I was multiplying by x minus 32, I would just end up with whatever's on the inside, x minus 32 with no root sign. Okay? If I had x minus 6x, x squared minus 6x, over something like this, times it multiplied by itself, x squared minus 6x minus 2. Same thing here. I would end up with x squared minus 6x minus 2. So whatever's on the inside of the root sign. So it's the same rule every time. So now at this point, we just collect like terms. So over here we get 256 minus 32 root x plus x. Now at this point, what we're going to do is start adding up. So we're over here, so we're going to start adding up like terms. So what I'm going to do is I'm going to bring the x over to this side, and I'm going to bring the number over here and see what happens. So now I have x, this becomes a negative when I bring it over, and the 32 becomes a positive when I bring it over to the right side. So 32 root x plus 256. So it becomes, so x minus x is just 0. So 0 equals, well, I did something wrong here. Sorry, this should be positive 32 because I brought the 32 over. 256 minus, yeah, sorry, okay. So now this becomes 0, 256 minus 32 root x. Okay, 256 plus 32 becomes 288. So that becomes 288. Now what we can do is bring this over to the other side, so then it becomes positive. Okay, now at this point what you can do is divide both sides of the equation by 32. Because 32 is in front of root x, you can divide it out, and when you do that, you end up with root x is equal to 9. And at this point, we're still not done. We want to solve for x, so we now ended up with a root x again. So what we're going to do now is we are going to square both sides of this equation, and we're going to end up with x is equal to 81 as our final answer. Okay, so what we did here is we just squared both sides of the equation, and squaring this side eliminates your root. So you end up with 81 as your final answer, and if you want to check if that solution is correct, what you can do is plug it into your original equation, and you should get that the left side equals the right side. So say we wanted to check our solution. So we have 81 minus 32 plus root of 81 is equal to 16. So let's check if it's correct. So root of 81, so this becomes root 49 plus root of 81 is 9. is equal to 16. The root of 49 is 7. 7 plus 9 is equal to 16. And this is actually correct. 16 equals 16. Therefore, we know our solution is correct. Okay, so we got the right answer. So that's a good example. So I'm going to do another example. So I'm going to try something like the following. So we want to solve for x again. So x minus 3 plus 1 over root x minus 3 is equal to root x. Now this is a good one. Okay, so first of all, when you have something on the denominator, you have a fraction, what you have to do first is eliminate that whatever you have on the denominator. And the best way to eliminate this is multiplying everything by root x minus 3. So what we're going to do is we're going to actually multiply everything by root x minus 3. So multiply everything by root x minus 3. So doing that, what happens here, so because we did it to everything in the equation, we're not actually changing the equation. So this is allowed. We're not changing the equation because we multiplied everything by root x minus 3. So now at this point, what we get here is this multiplied by each other is just going to give us x minus 3. So I'm just going to use a different color for this. So here we get x minus 3. Root x minus 3 times 1 divided by root x minus 3 just equals 1. And then finally we get root x. This one I'm just rewriting it in different order. So then at this point what we can do is collect like terms. So this becomes negative 3 plus 1. So x minus 2 is equal to root x minus 3. Now at this point, what you can do here is, okay, now I want to eliminate the roots. So what I'm going to do is I'm actually going to square both sides of my equation. So if you want, you can collect them under one root and then square it, or you could just square it first. So let's go ahead and square it. X minus 3 all squared, so that's just it multiplied by itself. X minus 2, so this just becomes x times x minus 3 when I square it. So what we end up getting is x minus 2 is equal to x squared minus 3x. So then I bring the x's to one side and the numbers to the other side. So when I do that, I get x minus 2 plus 3x, bringing the 3x over the other side, equals x squared. So this becomes x plus 3x is 4x minus 2 is equal to x squared. I did something not right here. Yep, I did do x squared minus 3x. Okay, you know what I did wrong? I forgot to square the left side. Okay, at this point here, I wanted to square both sides. So you're going to square, sorry, see, that's why the colors are good. So you want to square both sides. Whatever you do to the left side, you have to do to the right side. Okay, so we want to eliminate these. And Okay, so at this point, when we square this side, we get, over here we get x minus 2 times x minus 2, and then over here we just get x times x minus 3, because the root signs just eliminate when I square them. So now on this side I can use FOIL, so first terms, outer terms, inner terms, last terms, so I get x squared minus 2x plus 4 is equal to x times x minus 3. So then I get x squared, negative 2x minus 2x is negative 4x, plus 4 is equal to x times x is x squared minus 3x. So then bring all the x squares to one side and bring, I can bring this x over here and leave the number there. So x squared, this becomes negative x squared plus 4 is equal to negative 3x plus 4x. So x, this becomes positive x, so negative 3x plus 4x is just 1x. These eliminate and you end up with x is equal to 4 as your final answer. Yep, so that's correct. And if you want to check that solution, you can actually plug it into your original equation and see if you get the right answer, left side equaling to right side. So we can actually check it. So we got 4. So 4 minus 3 plus 1 over 4 minus 3 is equal to root 4. So 4 minus 3 is root 1 plus 1 over root 1 is equal to 2. And that is correct because we end up with 1 plus 1 is equal to 2. And 2 does in fact equal 2. So that is correct. So that would be your final answer. And I just checked my solution over here. Okay. I'm going to do one more example. So we want to solve for x. So we're going to have 1 over x plus, minus root x is equal to 1 plus x. So here what you're going to do is square both sides. Okay, square both sides first. So you're going to square both sides. So when you do that, you get root 1 over x minus root x times root 1 over x minus root x equals to, this just becomes 1 plus x, so the roots cancel each other out. So over here, you can FOIL these out. So this becomes 1 over x minus root x times root 1 over x minus root x times root 1 over x. And then root x times root x, negative root x times negative root x is just positive x. Okay, now here, 1 over x. Now this here just becomes x over x, because the x, you can collect them under one root. So same thing here, x over x plus x is equal to 1 plus x. So now, this becomes 1 over x minus 1, because it's just root of 1. X divided by x is 1, so, and then you get root of 1, which is just 1. Same thing here, root of 1 is just 1 plus x is equal to 1 over x, 1 plus x. So if I go ahead and continue, I get 1 over x minus 2 if I do these parts. And I'm going to bring this over to the other side. And when I do that, it becomes a negative. So that cancels that one. This becomes negative. So then I end up with 1 over x is equal to 1. I'm going to bring the 2 over, and it's going to become a positive 2. 1 over x is equal to 3. So 1 over x is equal to 3. Now to solve for x, we're going to multiply both sides by x. So when we do that, x times x is equal to 1, and this becomes 3x, and then I divide both sides of the equation by 3, so x is equal to 1 over 3, and that is the correct solution. And if you want, you can check it by plugging it into here and seeing if your left side equals your right side, and it actually should, because that is in fact the correct solution for that example. Okay, so that's another way, another one to try out. Okay, and I can show you that it's the correct solution by plugging it in if you'd like. So if we actually plug this in, we get 1 over 3. So I'm plugging in 1/3 into each x minus. So as you remember, the original question did not have the roots. Like these were not here originally. I added those after when I started rooting both sides. So minus root 1 over 3 is equal to root 1 plus 1 over 3. So here 1 divided by 1/3 is actually equal to 3 because the 3 ends up on the top. So 1 divided by 1/3 is the same as 1 times 3 over 1. If you flip the second fraction, change to multiplication, you end up with 3. So this becomes root 3. This is root 1/3. This 1 plus, that's just equal to 1 1/3. 1 and 1/3. 1 plus x, 1 minus, yep, okay. It doesn't look right to me. 1/3, 1 root, x minus 1 plus, okay. Let's see how that works out. Okay, so now 1 plus 1/3, 1 over, oh wait, this isn't correct. Yes it is, 1 1/3. Okay, so now 3 over 1, okay, let's write them like this. 3 over 1 minus 1 over 3 equals 1 and 1/3. So here I can collect this under all one root and just write as 3 over 1 minus 1/3. If I do that, if I multiply this top and bottom by 3, then I get 9 over 3 minus 1 over 3, which is equal to 7 over 3. This is not working out. I'm going to get 2 on the left side. Okay, let me just, I need to verify this here. So root 1 over x minus root x is equal to 1 plus x with the root. So what we did is we squared both sides. Yeah. We squared this side, so we got 1 over x minus x times 1 over x minus root x times 1 over x plus x. So then 1 over x, so this becomes x times, pretty sure this becomes x collected under one root. One plus x on the right, x 1 over x plus x. This becomes the negative, okay, plus x. So then we got 1 over x is equal to, yeah, so this x canceled, and then we got -2, which became a positive, and then we got 1 over x, 3x is equal to 1, x is equal to 1/3. Okay, this is the correct solution. Now I'm wondering why it's not working when we check it. So that's a little weird. Because this is giving me 2 1/3, and this is giving me 1 1/3, which I find very unusual. Our solution is 1 over 1 and 1/3. So root of 1 divided by 1/3 minus root of 1/3. So over here we get root of 1 divided, yeah, is root 3 minus 1/3 is 2 2/3.
This one? This one? That is boy and girl.
Something over here I'm not doing right. So I'm gonna rewind here and just check what I'm doing here. Okay, now, so the equation, the solution we got is the correct solution. So I'm just wondering what I'm doing. I'm doing something wrong here, so I need to check. Just when I check my solution, something's not happening. Okay, so let's see here. So this becomes a root 3, yeah, root 3 over 1 minus 1 1/3. So root 3 minus root 1/3. Just give me one moment. I'm going to check this on my calculator. Okay, I'm going to actually check this on the calculator. I'm going to take the root. No, there's none. This function's not on the calculator. Okay, just 1 second.
Because the bird bites. So she doesn't want to bite her hand.
Yeah, it does equal the same thing. Isn't that interesting? Okay, so root 4 over 3. So here I get, when I plug this into my calculator, I get 1.15470. And on this side, 1.73205 minus 0.57735. Yeah, so they do actually equal the same thing.
You don't want to do it?
No, we don't need to write the 0 here. So actually, when in doubt, you can always pull out your scientific calculator to check your solution. So I was having a bit of a, this here was like, gave me a little bit of trouble. Okay, now I know why. Okay, so you could work it out using calculators, or you can, okay, so if we wanted to work this out, what I would do is change everything to fractions first. So that would become root, okay, where should I write this? Okay, so just going from this line here, I want to verify that root 3 over 1. Okay, so I'm just going to verify it. So I'm just going to erase some stuff here. I just don't know where. Maybe I can just write it over here. Okay, so I'm just checking this part here. So this would be root 3 over root 1 is equal to minus 1 over root 3. So you can actually write them each with roots is equal to, and the other one's 4 over 3. So that, okay, so that's the first part. So, okay, so now this part here becomes root 3 over 1 minus 1 over root 3 is equal to root 4 over root 3. So just writing them in roots and simplifying. So what I did here is I just eliminated the root 1s. I just wrote 1 instead. Now here, if I want to get the same denominator here, I have to multiply the top and the bottom of the left, this one here, by top and bottom by root 3. And when I do that, I get 3 over root 3 minus 1 over root 3 is equal to root 4, which is 2 over 3. Root 3, sorry, there's still a root on the bottom. There's still a root on the bottom here. Okay, this root 4 becomes 2, and then 3 minus 1 is 2 over root 3. Yeah, so it is the same. I don't know why I couldn't figure that out earlier. Okay, so yeah, so you can either go ahead and pull out your scientific calculator, but you can also do it with roots. So from this step here, when I was checking my solution, so what I did is I just cleaned things up a little bit. So I wrote it up as root 3 over root 1, which you're allowed to do because you've got one root. You can write them as 2 roots like this, rewrite it in a different form, minus root 1 over root 3 is equal to, and then I wrote the mixed fraction as an improper fraction. So 3 times 1 is 3 plus 1 is 4 over 3. So I wrote it there so that this equals this. And then, okay, maybe I should have wrote that like this, equals to root 4 over 3. Maybe that should have been written in one line so it's not confusing. Like that. And then in the next line, so then at that next point, what I did is I simplified. So the root 1s, I know that they equal 1. The root of 1 is 1. So I wrote those out. And then for this part, I just wrote them both with roots. And then the next step was to get common denominators on the left. So what we did is we multiplied the top and the bottom of this one by root 3 so that we can have the same denominator for both our fractions since we're subtracting fractions. So this again takes us back to the rules of subtracting fractions. So whatever we do to the bottom of the fraction, we do the top. So we did that and we got root 3 times root 3, which is 3, and then 1 times root 3 is root 3, minus 1 over root 3, and then root of 4 is 2, so I wrote that out, over root of 3. Okay, so that's what we did there. And then finally, over here, because we have the same denominator, we can go ahead and subtract the numerators. So it becomes 3 minus 1, which is 2 over root 3. 2 divided by root 3 is equal to, and then this here is just 2 over root 3. So we now see that the left side of the equation does equal the right side. Therefore, that is the correct solution to this equation. Okay, so I hope you were able to follow that. It got a little bit messy, but so that's our lesson on radical equations.